Hello, ladies and gentlemen, and welcome back to Chapter 12, where we're talking about chemical solutions. And this is the second part of that process. Okay, first off, the process that we're going to talk about today is called solvation. Do not confuse this with salvation or salivation. This is solvation. Okay, this is a process you're very familiar with on a personal level, and that is simply dissolving a solid into a liquid. Okay, that's the name of it, solvation. Okay, now the process is probably a little more complicated than you think when you dump the sugar into your tea, but it is not insanely complicated. So here we go. Okay, the process of solvation. You start with a solute and a solvent. Remember, in this scenario, it's a solid into a liquid, so the solvent would be the liquid, and the solute is whatever is getting dissolved into the solvent, and it would be a solid like sugar or salt, something like that. Okay, the first part of solvation is when you have the solute use energy from the solvent. In that situation, it takes energy from its environment and it expands, it spreads out. Okay, you need to have the solute start coming apart in the process. Now, for the solvent, that's the second part, and that is where it also will take energy from the environment and it will expand. Okay, you have to have them expand because in order to dissolve, you have to have spaces between these substances for them to mix together. And in order for the substances, whether solute or solvent, to expand, it must take energy from its environment. So what you might notice at this point is if there's a chemical reaction going on, you might actually be able to detect a slight temperature drop. Depends on the type of reaction as to exactly how much of that. But no matter the situation, there is energy being taken from the environment for this to happen. Now, the expanded solute and the expanded solvent then will need to come together in order to create the new solution where you have the solute dissolved in the solvent. Now, when they come together, it's kind of like with bonding, except it's a physical connection. Energy is actually given off. So, because it's now more of a stable situation. So, when it's expanding, it's using energy, and when it comes together as a mixture, it actually will release a little bit of energy. Now, these steps, depending on the type of chemical reaction, will use different amounts of energy. Some things are harder to come apart. Some things give off a lot of energy when they come together, some only a little bit. So it really depends on what the chemical reaction is as far as what amounts of energy are being taken from the environment and what amounts are being given off. Now you'll notice when we talk about the heat, the energy, it's from the perspective of the solution. So when it's using energy, it is taking it in to the solution. So it's increasing the amount of heat. The little triangle there just means a change. So the positive means it is going into the solution. The triangle is called delta. It's the Greek letter D. So it's a change in and heat. So positive delta H, the energy or the heat is going in, and a negative delta H, the energy is going out. Okay, so you do it from the solution's point of view. Now, these energies lead us to a measurement. If you have the dissolving of the solute, remember that it is positive delta H, which uses energy. You have the dissolving of the solvent, same thing, positive delta H energy. And when they come together, they give off the heat. And the combination of the energy of these three things coming together is called enthalpy. Do not confuse this with entropy. Entropy, remember, is the amount of disorder. Enthalpy is the overall heat or energy of a chemical reaction. Now, if the enthalpy of that reaction is negative, okay, so you add all these up and it's negative, that means it is what's called exothermic. Ex, means out, therm is heat, it's heat given off. So if in this case, if you have a chemical reaction and you were feeling or measuring the heat of that reaction, it would be getting hotter. Okay? So you would feel the beaker or whatever getting warm. Okay, this would be if you're talking about combustion or some of those explosions you saw, things like that. Now, if the enthalpy is positive, okay, you add them all together, that means it's endothermic. Inside heat, the heat is taken in to the solution. Okay, and that one would feel cold. So if you were touching it, it might feel colder than the surroundings. It might almost feel like ice. Sometimes the reaction could be colder than ice. Now, there are different types of solvation. The most basic type is if you're talking about dissolving a covalent substance like sugar into water. This is called hydration. Anything that's being dissolved in water is hydration. Okay, you can't think of it the same as, you're thirsty, you drink water, you're hydrated. It's not the same thing. This means that things are being dissolved in the water. Now what you can see, we have this cute little image up here, that in covalent solutions the molecules don't break up. Okay, so you take this sugar molecule here, you dump it in the water, and what you'll see is you still have these complicated sugar molecules. They don't separate. The atoms that make up that sugar, the C6H12O6, are all still together. Now, they're not going to be a big lump of sugar. You can't see them when you dissolve sugar in water, but it's still sugar and water. Remember, this is a physical combination, not a chemical one. But the sugar is staying intact down to the molecular level. Now, there is an exception to this. It does not happen very often. But basically what happens is you have something called ionization. This is more rare. An ionization, although you would think, is dealing with ionic things, don't let the name fool you. Ionization is dealing with covalent compounds. Okay, and you can see right here you have water, which hopefully by now you know is covalent. Okay, but what happens is if you have water dissolved in water, I know that sounds strange, but some of it will actually become ions. You'll have the hydrogen from one of the waters go over to the other, and you'll have the electron left, and you'll have just OH with a negative charge and H3O with a positive charge. So these covalent compounds actually become ionic. when they're dissolved. This is rare. Most of water does not turn into these things, but if you went and you could look at all of the atoms of the water, there would be these ions, even though you started with a covalent substance. In fact, two covalent substances. Okay, so it doesn't happen very often, but it does happen. Ionization is when covalent compounds become ions. Now, one that you're pretty common with is ionic solutions. It is still considered hydration when you have it in water, even if it's ionic. But what you can see up in the corner is we have a sad series here of atoms, because in ionic solutions, the atoms do not stay together. You can see the sodium and the chloride, all these little blue things, hopefully you can recognize as water. What happens with ionic substances is because they have those charges and because water has the charges, there is dissociation. Okay, association, things come together. Dissociation, things come apart. So in ionic solutions, there is dissociation. The NaCl, or whatever the ionic compound is, actually breaks apart down to the atomic level. It doesn't stay as a compound. It's not NaCl floating around. It's Na with a positive charge and chlorine with a negative charge. Okay? If you have questions, make sure you ask, and we will talk next time.